Let's start by looking at an overview of the type of reactions and basic concept of organic reaction mechanisms. So organic reactions can be studied based on their types and their mechanisms. So under types of organic reactions, we study the what of an organic reaction. For instance, when compound A and B react with one another, what type of products are formed? Are they an addition, a substitution, an elimination, or a rearrangement product? So recognizing the products is fundamental to understand organic reactions. One has to know the product of the reactions of compound A and B, for example, or at least recognize the type of product that is formed. So once we have a clear understanding of this, and then we study reaction mechanisms. So to understand organic reactions, it's not good enough to know what are the products of the reactions of compounds A and B. We have to also know how compound A and B react to give a particular product. We have to know the different steps compound A and B go through as they form product. Which bond is broken or formed to initiate the reaction? Why are these compounds A and B are going to react with one another in the first place? So the how and the why of organic reactions is studied under reaction mechanism. So first we'll study the types of organic reaction, and then once we have a clear understanding of that, we'll study their reaction mechanism. So before we look at the different type of reactions organic compounds undergo, let's start by defining what a chemical reaction is. A chemical reaction is basically a transformation of chemicals. One chemical compound can be transformed into product. It could be two or more reactants could react with one another to give a single product, or a combination of reacting species could react to give a combination of different products. This is basically what a chemical reaction is, a transformation of chemicals. Compound A being transformed into compound B, etc. Of course, during the course of a chemical reaction, what happens is bonds are going to be broken and bonds are going to be formed. So during the course of a chemical reaction, there will be breakage of old bonds and formation of new ones. Then we look at the different type of reaction organic compounds undergo. The majority of the reactions organic compounds undergo can be divided into 4 categories. Organic compounds undergo thousands and thousands of reactions. The majority of the reactions organic compounds undergo can be grouped into 4 as addition reaction, substitution reaction, elimination reactions, and rearrangement reactions. So what happens during the course of this reaction is already indicated or implied in the name. During an addition reaction, 2 reactants will add to one another to give a single product. In a substitution reaction, part of the reacting species will exchange with each other to give a product. During an elimination reaction, from the reactant, certain groups will be eliminated to give 2 different type of product. And the last one we are going to look at is rearrangement reaction. So as the name implies, as the reactant become products, the only thing that has happened is the reactants, they change their position. So these are the 4 major type of reactions organic compounds undergo. We need to recognize each of these. So for us to have a clear understanding of this, let's look at each of these with example. The first one we'll look at is an addition reaction. So an addition reaction is a reaction where two reactants react with one another to give a single product. It's a reaction in which one adds into another, one reactant add into another to give a single product. This is a reaction where two molecules become one. Is called an addition reaction. So one of the most important example of addition reaction is the reaction of alkenes with halogens to give an addition product. This is a reaction of an alkene with bromine to give an addition product. This is a reaction you're probably familiar with from your organic chemistry in high school. You remember one of the tests for alkenes is the decolorization of bromine. So the bromine solution will get decolorized when alkenes are reacted with bromine, because the bromines add to the carbon-carbon double bond. In the process, they get consumed, so the solution gets decolorized. So what happens during the course of an addition reaction like this, that the two bromine atoms add to the double bond carbons. One of them adds to this carbon, the other one adds to that carbon to give this addition product. So if you look at this double bond, it's composed of sigma bond and pi bond, but in the product we're only left with a sigma bond. So during the course of an addition reaction, a pi bond will be broken, but instead we have two new sigma bonds being formed. So you have a sigma bond being formed between this carbon and this bromine, this carbon and this bromine. So in the course of an addition reaction, a pi bond is broken and two sigma bonds are formed. The type of compounds that undergo addition reaction are unsaturated molecules. They must have either a double bond or a triple bond. Such type of compounds, since they are unsaturated, they undergo an addition reaction. So another example we look at is the addition of HCl into an alkene. So in this reaction, the hydrogen will add to one of the carbons of the double bond, and then the chlorine will add to the other. So as you can see here also, this pi bond is broken, and then two new sigma bond, this carbon hydrogen bond, this carbon chlorine new sigma bonds are formed. In summary, during the course of an addition reaction, a pi bond will be broken and two new sigma bonds will be formed. The second type of reaction is substitution reaction. So in a substitution reaction, as the name implies, it is basically exchange of groups between the reactants as they form product. For example, when you react compound AB, which has got a bond between A and B, when you react it with CD, which has got a bond between C and D, what happened during the course of this substitution reaction? B and C interchange. So C will replace B, B will replace C, giving us a product AC and BD. So basically, one group replaces another during the course of a substitution reaction. Let's just look at some example. So the first example I'm going to give you is a reaction you are very familiar with from your chemistry studies in high school. You remember in high school we studied the reaction of a base with an acid. When you react a base with an acid, you get water plus salt. This is an example of a substitution reaction. As you can see, when HCl reacts with sodium hydroxide, the OH of sodium hydroxide replaces the chlorine of HCl to give HOH, which is basically water, and then the sodium of sodium hydroxide replaces the hydrogen of HCl to give sodium chloride. A substitution reaction. Another example of a substitution reaction is the reaction of an acid chloride with OH, could come either from sodium hydroxide or potassium hydroxide. When you react an acid chloride with a base like minus OH, what's going to happen? The OH is going to substitute the chlorine in the process. The acid chloride will be converted into a carboxylic acid. The OH and the Cl exchange. So this is a substitution reaction. Another example of a substitution reaction, which you are familiar with from your high school organic chemistry, is the reactions of alkanes with halogens in the presence of light, where you get a substitution product. For example, when you react methane with chlorine in the presence of light, the hydrogen of methane will be substituted by chlorine, so you get a chloromethane product, and then one of the chlorine of the chlorine molecule will be replaced by hydrogen to give us HCl, a substitution product. Later on, we are going to study in detail this reaction. We want to study, first of all, why this reaction does not take place without light, why it cannot happen in the dark. What is really the role of light in this reaction? When methane reacts with chlorine and they form this product, which bond is broken first and which bond is formed? Why are the bonds broken? Why are the bonds formed? We'll study in detail the mechanism of this reaction. What are the different steps methane and chlorine undergo in the presence of light to give us chloromethane and HCl. The third reaction we are going to look at is elimination. So elimination basically involves removal of certain groups from a reactant to give two different products. As you can see, it is exact opposite of addition. In addition, we have two reactants reacting with one another to give a single product. But in this case, a single product splits itself to give two different type of product. This reaction is called an elimination reaction. It is a splitting of a single reactant into two different products. It's called an elimination reaction. Let's look at some example. So this is an elimination reaction. From this reactant, this hydrogen and this bromine are eliminated to give us these two different products. So this one, the hydrogen and the bromine, are eliminated with the assistance of a base to give us HBr and an alkene. So as you can see, during the course of this reaction, these two sigma bonds, this carbon hydrogen and this carbon bromine sigma bonds, are broken, and then instead we have a pi bond formed, exact opposite of an addition reaction. So this reaction is a method chemists use, organic chemists use, for purpose of preparing compounds that have multiple bonds, either double bond or triple bond. So when certain atoms are eliminated, you get compounds that have multiple bonds. So this is a method of preparation of unsaturated molecules. In general, during the course of an elimination reaction, the exact opposite of addition reaction happens. Two sigma bonds will be broken and a pi bond will form between adjacent atoms. So this hydrogen and the bromine are eliminated or removed from adjacent carbons, and then these carbons that are next to each other in the product will have a carbon-carbon double bond, a new pi bond. So addition and elimination reactions are exact opposite of each other. So if you look at this reaction, this is an unsaturated molecule. So since it is unsaturated, it will undergo an addition reaction. So when you react with XY, whatever X and Y are, these ones will add to the carbon-carbon double bonds, giving an addition product. So X could add to this carbon, Y could add to the other one, giving an addition product. So during the course of this reaction, a pi bond will be broken and two new sigma bonds will be formed. So the reverse reaction, formation of these from here, is going to be an elimination reaction. So you eliminate X and Y. So when X and Y are eliminated, a double bond will be formed. So during the course of this reaction, a pi bond is formed and X and Y are eliminated. The bond between this carbon and X, this carbon and Y, these two sigma bonds are broken and you have a pi bond formed. The last reaction is rearrangement reaction. So rearrangement reaction, as the name implies, the products are rearranged forms of the reactant. So for example, when you react this alkene, when you treat this alkene with an acid, it rearranged to give this other alkene. So for some reason, this must be more stable than this. That's why this is transformed into this. But when you look at both of them are alkenes with carbon-carbon double bonds. So if you look at this molecule has got 1, 2, 3, 4, 5, 6 carbon, just like this one. 1, 2, 3, 4, 5, 6 carbons. And then you have 3 hydrogen here, another 3, another. So these are 3 plus 3, 6, plus 3, 9, 10, 11, 12. And then we have 3 plus 3, 6, plus 3, 9, plus 3, 12. So both of them basically are C6H12. The only thing that happened during the course of this reaction, the atoms changed position. So this is a rearrangement reaction. Reactant and products are basically isomers of each other. So to summarize, the majority of the reactions organic compounds undergo can be categorized into 4 groups as addition, substitution, elimination, and rearrangement reaction. I want you to take your time and understand them. We have understood the what of an organic reaction, what type of products are formed during the course of an organic reaction. Next, we'll look at the how and the why of an organic reaction. That means reaction mechanism. So our next lecture is going to be on the basic concept of organic reaction mechanisms. See you then.